Scaffolding is a temporary structure from which person can gain access to a place of work in order to carry out building operation. It includes any working platform such as ladders and guardrails. This is first example of scaffolding, which is woodblock scaffolds. It's mostly used for buildings of traditional brick construction. This is example of building that use woodblock scaffold, which is Cal Castle at Perak. So this is independent tight scaffolds. It consists of double row of standard with each row parallel to the building, and the inner row is set as close to the building. Then this is scaffold towers, or known as mobile tower. It provides access platform for works on ceiling. It is easily movable and freestanding.
Birdcage towers is also known as independent tower. It consists of more than two rows in both directions. A birdcage scaffold consists of a mass of standards arranged at regular intervals in parallel lines. Birdcage. The picture shown is the real-life birdcage tower. Next is roof saddle and stack scaffold. Roof saddles are generally erected when minor repairs are made, example by replacing chimney, pots, and repointing. A roof stack is used because of the position of the chimney requires an access scaffold. Roof stacks are erected when more substantial repairs are required, example in demonstration and rebuilding of chimney in situation
It's a simple fact. In order to do your job, you first have to get to where you work. Some people take a flight of stairs. Others use elevators or escalators. But what if your job requires you to work suspended in midair, 30 feet up? In that case, you need something much more specialized to get there, like a scaffold. When you are working high above the ground on structures like scaffolds, safety is especially important. In fact, scaffold safety is such a critical issue that OSHA has developed regulations specifically dealing with working on scaffolds. And while there are many kinds of scaffolds covered by the OSHA regulations, this program will focus on suspended scaffolds. Suspended scaffolds are made up of one or more platforms that are hung by metal or fiber rope, which allows the platforms to be raised and lowered to reach various work locations. These scaffolds allow workers to safely reach places that are normally difficult to get to. Suspended scaffolds are like any other tool. There are certain procedures that need to be followed to make sure that no one gets hurt when they are used. That's why workers must be trained on the rules and safety regulations for suspended scaffolds before being allowed to use them. OSHA mandates that this training include the proper ways to assemble and take down suspended scaffolds, their correct use and placement, how to handle materials while working on suspended scaffolds, and fall prevention and protection techniques. And even though workers must undergo this thorough training, OSHA also requires that a scaffold expert be on site at all times, whenever scaffolding is being used. This expert is responsible for designing each scaffold that is erected at the site, supervising scaffold construction, enforcing scaffold safety regulations, and resolving any problems that relate to scaffolds. There are a number of hazards that you have to be concerned about when working with scaffolds. To start, it is important to check the area where your scaffold will be used before you even begin setting it up. Look for things that could block the scaffold's path while it is in motion. Protruding objects, like pipes and construction equipment, could very well tip the scaffold as it passes by. Electrocution can also be a hazard when you are working on a suspended scaffold. Make sure you are a safe distance from all electrical sources. Be especially aware of any nearby power lines that could come in contact with the scaffold. The rule for working near power lines is the higher the voltage, the further away you should be. Ask your supervisor about how far away you should be from any lines around your worksite. After your site has been inspected for obstructions and other hazards, you can move ahead with hanging a scaffold. A scaffold expert will decide which suspension device will best fit the structure that you are working on. There are a number of suspension devices to choose from, including cornice hooks, parapet clamps, and roof irons. These must be attached to parts of the structure that are strong enough to support 4 times the maximum intended load of the scaffold. OSHA defines the maximum intended load as the total weight of a scaffold, including an estimate of all persons, equipment, tools, and materials that can be applied to a scaffold or scaffold component at any time. All suspension devices must be made out of wrought iron, steel, or a material equal in strength to these metals. When there are no points on the structure that can support a suspended scaffold, outrigger beams are used. These beams are anchored to bearing supports within the structure and extend the scaffold out and away from it. For best results, outrigger beams should be placed perpendicular to their supports, unless it is determined by a scaffold expert that it is safe to attach them at a different angle. The beams should then be stabilized with ropes known as tiebacks. Like the scaffold itself, the tiebacks must be strong enough to support the maximum intended load of the scaffold. They should be securely anchored to bearing supports, like a building's I-beams and girders, not things that could give way, like vents, pipes, or electrical conduit. To further stabilize the outrigger beams, counterweights should be attached. This creates a balance between the weight of the scaffold and the weight of the support beam. But be sure to only use weights that are designed specifically to act as counterweights. Don't use construction materials because other workers might think they are available for their normal use.
There are several advantages and disadvantages of scaffoldings. The first one is safety. It provides stable platform to workers, ensuring safe even at high level. The suitable level area for workers to move around. The second one is ease of access, to navigate the outside of building easily and safely. It also provides level of platform for workers. The third one is multiple workers, to provide ample space and support for a team working in the same area. The scaffolding will often be relied upon. The fourth one is too easy to set up. It is designed to be lightweight, quick to assemble, strong to support workers, and easy to take down. It is also ideal for temporary construction that want a fast solution to working. The disadvantages of scaffolding is the first one, skilled staff. It requires skilled staff in many situations to put it up and down, which lead to extra costs. Second one is time. It takes more time to put scaffolding up compared to other solutions. The third one is cost. The longer time it is being used, the higher the cost.
Deck shoring. This is one of example of the structure of deck shoring. It consists of head piece at here and prop and wall at this. This is called deck shoring. The purpose of deck shoring is used to support the load with X vertical downwards. The usual arrangement is to use two stolets connected over their head by a horizontal beam or needle. That's all.
U.S., more than 800 construction workers die every year while on the job. Falls are the #1 cause of fatalities in construction. Falls cause 1 of every 3 construction worker deaths. These falls happen in a split second while workers are on roofs, scaffolds, ladders, bridges, and other work surfaces. But these deaths can be prevented. The video you're about to see shows how quickly falls at construction sites can lead to workers' deaths. The video will also show what employers must do so that the work can be done more safely. Employers have a responsibility to provide a safe workplace and required protective equipment. You'll see that using the right type of fall protection saves lives. Please be advised, the scenes you're about to see deal with deaths at construction sites and might be disturbing for some people. All scenes are based on true stories. A worker was installing vinyl siding on a 2-story townhome. He was standing on a ladder that was placed on top of a scaffold. A coworker was on the scaffold cutting pieces of siding. The scaffold had no guardrails. The workers were not wearing any fall protection. While standing on the top step of the ladder, the worker putting up siding overreached to one side and the ladder overturned. He fell nearly 20 feet and landed on the driveway below. He died later that day from injuries caused by the fall. Let's look at the events leading up to this tragic incident and see how it could have been prevented. Originally, the worker installing siding was standing on a ladder that was placed on top of a scaffold. This is a very serious and dangerous OSHA violation. Also, there was no fall protection for these workers. OSHA requires employers to provide workers with fall protection when they're working on scaffolds more than 10 feet above a lower level. Let's look again at the worker installing siding. But now, the worker is standing on a fully decked pump jack scaffold. It has guardrails at the top, middle, and ends. So instead of being at risk from falling while installing siding, this worker is now protected from fall hazards. This example shows the importance of employers following OSHA's fall protection standards to ensure that workers are provided with a safe workplace. These types of construction deaths are preventable. The fall protection measures shown here save workers' lives. Use fall protection on the job. It could be the difference between life and death. If you would like more information, contact OSHA at www.osha.gov or 1-800-321-OSHA. That's 1-800-321-6742.
So this is the raking shore. It is an incline shoring. So the following points are to be kept in view for the use of the raking shores. Rakers are to be inclined in the ground at 45 degrees. However, the angle may be between 45 degrees and 75 degrees. For tall buildings, the length of the raker can be reduced by introducing rider raker. Rakers should be properly braced at intervals. The size of the raker is to be decided on the basis of anticipated thrust from the wall. The center line of a raker and the wall should meet at floor level. Shoring may be spaced at 3 to 4.5 meters spacing to cover longer length of the bar. The sole plate should be properly embedded into the ground on an inclination and should be of proper section and size. Wedges should not be used on sole plates since they are likely to give away under vibration that are likely to occur.
segment is about the construction of solid sole rakers. Typically we're going to build them as either 45-degree solid sole rakers or 60-degree solid sole rakers. If we're building on soil and not a surface like concrete or asphalt, typically we're going to choose the 60-degree rake because it has maximal height with minimal horizontal force application. For today's application, we're going to do solid sole 45-degree raker and also discuss the variables for the 60-degree raker. The first thing you need to determine when constructing these is what your insertion point is going to be. The insertion point is the level of height or the point at which you want your raker to contact your wall plate. That area needs to be at or below 2 feet within that window of your flooring system and where it ties into the wall. So insertion point typically is going to be somewhere around the 8-foot to 10-foot mark with most commercial structures. So for this raker that we're going to build today, we're going to go with an 8-foot insertion point. Once you have that insertion point established, if you're building a 45-degree raker, you have a 12-12 rise, run, or pitch. So if we're inserting at 8 foot on the wall, we know that we're going to have a collection point that is roughly 8 feet on the sole plate. If we're building the 60-degree raker, then we have a 12-7 pitch. So for every 12 inches of rise to equal that 8-foot insertion point, we're only going to have 7 inches of run for our collection point on the sole plate. Once you have those calculations established, you can use 2 coefficients that are in the FOG manual. One of them is 14 and one of them is 17. The 17 coefficient applies to 45-degree rakers and the 14 applies to 60-degree rakers. So to use that in a calculation method, you're going to take your insertion point of 8 feet. For a 45-degree raker, we would multiply that 8 times 17, giving us a total of 136 inches, or 11 foot 3 inches. That is the length of our raker. Another thing that is a good indication for us that we can be aware of before we even start fabricating is some of the determining factors or the cutoffs with raker design. So if a raker itself is greater than 11 feet in length, we know that we're going to need midpoint bracing. With an 8-foot insertion point, you're going to be at 11 foot 3 inches, so we can already start pre-planning for that midpoint bracing and establishing that.
Right now I'm gonna explain about the one of the shoring system that will be used in the construction. One of the shoring system that will be used in the construction called flying shores. Flying shore are used to provide temporary support to 2 parallel wall or 2 parallel structure or 2 parallel for example trench, which otherwise may collapse if we don't use the flying shores. A flying shores consists of wall plate, strut, staining piece, horizontal shore, needle wedges, and cleats. Flying shore are most often used to support temporary parallel wall of 2 adjacent building, which an intermediate building has to be demolished or to be rebuilt. Essentially, the scaffolding would be built through the middle and wedge between the adjacent building. If we want to rebuild or to demolish the 2 wall, between 2 wall, we will use flying shores, and usually scaffolding will be placed at the middle of the wall of the 2 adjacent walls, so we can use the scaffolding to provide support or to make the easier more. This is a specific high-end design element. Often the use of flying shore will be need to be constructed by a professional, and will have to use the planning regulation system. Okay, the flying shore basically is same function as raking shore. It's just the same to provide support. The advantage of using flying shore is to provide a clear working space under the shoring and use between any parallel wall surface provide the span. Okay, next I'm going to show a video about the flying shore.
Workers shall not enter any excavation over 4 feet in depth unless the sides of the excavation are sloped to a safe angle. The sides have been supported by the use of sheet piling or shoring and bracing, meeting the minimum standards contained in the regulations. Or the workers are protected by other effective means, such as restricting worker access to the hazardous area. When sloping is used instead of shoring, depending on the conditions, no slope can be steeper than 3 feet horizontal to 4 feet vertical. When a combination of sloping and shoring is used, the minimum amount of shoring must be equivalent to the standard for the overall depth of the excavation. Shoring is installed from the top down and removed from the bottom up. The reason is so workers will always be protected by the shoring that's in place. In other words, the trench is excavated. Uprights, upper stringers, and cross braces are put in place. Then the lower stringers and cross braces are put in place. The number of stringers and cross braces needed is dependent on the depth of the excavation. When the job is finished, the lowest cross braces and stringers are removed first, and then the uprights. In other words, in reverse order. Then the site is backfilled. But no workers are allowed in the trench to compact the backfill. Excavation support systems must be installed so that they are firmly in contact with the face of the excavation. This can be achieved by backfilling or blocking. Support systems must be inspected daily or more frequently if required, and must be maintained in a fully effective condition. This is the site manager's responsibility. Shoring uprights must extend above the top of the excavation by at least 1 foot and must be as close to the bottom of the trench as is possible, but in no case more than 2 feet from the bottom.
Okay, I will explain the system in the shoring. First of all, we use aluminium in the shoring because it can carry maximum leg load capacity. Next, it also requires a smaller workforce because of its simplicity, speed of erection, and checking of bracing. It also provides a rigid connection that greatly reduces the effective length of struts formed by standard. It also has a comparison between scaffolding and shoring. I will explain for the scaffolding first. It is a temporary elevated and its supporting structure used for supporting workers, material, or both. For the shoring, It is a vertical supporting member in a formwork system.
Shoring is the process of temporarily supporting a building, vessel, structure, or trench with shores, props, when in danger of collapse or during repairs or alterations. Shoring comes from shore, a timber or metal prop. Shoring may be vertical, angled, or horizontal. Raking shores consist of one or more timbers sloping between the face of the structure to be supported and the ground. The most effective support is given if the raker meets the wall at an angle of 60 to 70 degrees. A wall plate is typically used to increase the area of support. Shoring is commonly used when installing the foundation of a building. A shoring system such as piles and lagging or shotcrete will support the surrounding loads until the underground levels of the building are constructed. During excavation, shoring systems provide safety for workers in a trench and speeds up excavation. In this case, shoring should not be confused with shielding. Shoring is designed to prevent collapse, where shielding is only designed to protect workers when collapses occur. Concrete structures shoring, in this case also referred to as false work, provides temporary support until the concrete becomes hard and achieves the desired strength to support loads. Hydraulic shoring is a use of hydraulic pistons that can be pumped outward until they press up against the trench walls. They are typically combined with steel plate or plywood, either being 1-1/8 thick plywood, or special heavy Finland form, Finform 7/8 thick. Beam and plate steel I-beams are driven into the ground and steel plates are slid in amongst them. A similar method that uses wood planks is called soldier boarding. Hydraulics tend to be faster and easier. The other methods tend to be used for longer-term applications or larger excavations. Soil nailing is a technique in which soil slopes, excavations or retaining walls are reinforced by the insertion of relatively slender elements, normally steel reinforcing bars. The bars are usually installed into a pre-drilled hole and then grouted into place or drilled and grouted simultaneously. They are usually installed untensioned at a slight downward inclination. A rigid or flexible facing, often sprayed concrete or isolated soil nail heads may be used at the surface. Shoring is used on board when damage has been caused to a vessel's integrity, and to hold leak-stopping devices in place to reduce or stop incoming water. Generally consists of timber 100 mm x 100 mm and used in conjunction with wedges to further jam shoring in place, pad pieces to spread the load and dogs to secure it together. Also used on board is mechanical shoring as a quick, temporary solution, however it isn't favored due to its inability to move with the vessel. Vertical shoring, this is to support a hatch or splint box on the deck, consisting of a vertical timber between the deck and deck head, with two wedges used opposing each other to tighten it. Pad pieces are used to spread the load on weak structures. Square shoring. This consists of a timber member jammed on a pad piece on either the deck or deck head depending on water levels in the compartment and a strong point. This is called the proud. Then there is a horizontal timber cut to size to fit between this and what it is shoring up, for example a splinter box, bulkhead or door. Timber wedges are then used to tighten up the structure if necessary.